Welcome to AI World TV, your go-to destination for everything artificial intelligence. Discover the captivating landscape of AI, where advanced technology finds real-life application. Subscribe to AI World TV for webzine articles, reports, podcasts, videos, live events, and latest trends. Hear from top industry leaders and discover how AI is transforming industries and our daily lives.
Okay, so let's just dive right in. If you're involved in, modern business at all, you know that automation isn't new.
Not at all.
But the entire premise, the whole foundation of enterprise automation is going through this. This fundamental structural change. We're moving beyond the simple scripts of robotic process automation, RPA, and we're entering this highly adaptive world of autonomous AI agents.
And it's so much more than just a new tool. It's really a shift in how work itself is conceived. So I think our mission in this deep dive is to explore the three essential practical layers driving this. We're talking about the necessary infrastructure that actually hosts this intelligence, the radically changing total cost of ownership, the economics of it all, and this profound geopolitical reality that is sovereign AI.
And before we get into the weeds, let's just anchor ourselves to the core insight from all the material. We are not witnessing AI replacing tools like RPA.
No, not at all. It's the opposite, really.
We're seeing augmentation. The future, it seems, relies on creating a collaborative enterprise intelligence where the reliable deterministic stuff and the new adaptive stuff work together as a single unified utility. You really need both.
Yeah.
So let's start at the very foundation of this, the anatomy of autonomy. When we look at this shift from the automation we've known for years, what is the core difference? What separates the old deterministic bots from these new autonomous AI agents?
Well, the difference really boils down to the core logic, and it's critical for you to understand this. Traditional automation, RPA, is deterministic.
Okay.
Think of it like a recipe. It is strictly rule-based. It follows step A, then step B, then step C, and it does that perfectly every single time, no deviation.
So a script, it just executes a script.
Exactly. The agent, however, is completely different. It's probabilistic and it's reasoning-driven. It doesn't follow a script. It's given an objective. So if RPA's goal is simple task execution.
Right. Following the recipe.
The agent's goal is objective fulfillment. It has to dynamically figure out the plan, the steps A, B, and C all on its own, and it has to adapt if the environment suddenly changes.
So, okay, if a website interface suddenly changes, the deterministic RPA bot, it just breaks because step B isn't where it expects it to be.
It's done.
But the agent, in theory, looks at the new interface, it reasons, and then decides, okay, the button moved, but the intent is the same, so I'll click over here instead.
And that is the power of its high adaptability. But, and this is a huge but, that introduces a critical conflict. RPA's deterministic reliability is its greatest strength, especially for compliance. In regulated industries like, say, banking or pharma, you need to know that the machine follows the exact same rules every single time.
Wait a second. If the agent's whole goal is objective fulfillment, figuring things out on its own, doesn't that fundamentally clash with the need for strict auditability? I mean, how do you even begin to govern something that's inherently non-deterministic?
You just hit on the crucial nuance. The trade-off for all that adaptability is a huge jump in complexity for control. Because agents are contextual and probabilistic, they require extensive governance frameworks right from the start. You have to build systems to trust that the agent will make the right call, and you have to be able to audit that decision process. But on the flip side, what's really exciting is how this democratizes access. RPA required IT or, developers to write those rigid scripts.
Right.
Agents, they move that control over to the business users. They can just define the objective they want fulfilled. It really empowers the non-developer.
So let's go inside the machine. What does an autonomous AI agent actually look like structurally? If it's built for this kind of goal-oriented action, what are its component parts?
We can break the architecture down into four essential components. First and foremost, you have the reasoning engine. This is the part that's powered by the large language model, the LLM. It's what we all call the brain.
Okay, the brain.
It interprets human intent, it breaks down these complex objectives, and it generates the dynamic action plans.
So the brain interprets the request and decides what to do. But I mean, for any decision to be good, it needs context.
Precisely. And that context lives in the second component, the memory module. This stores short-term context from, the immediate session. It stores historical data, and crucially, it stores long-term enterprise knowledge. Think of all the standard operating procedures, the SOPs, that define how a business actually runs. The agent can't generate a plan in a vacuum.
Got it. So we have the brain and the memory. What lets it actually do things in the world?
That would be the third component, the planning and execution toolset. This is the agent's toolbox. It selects and uses the necessary tools to perform the actions it just planned. And here's where the old meets the new. That toolset absolutely includes legacy RPA bots.
So it can call on the old guard.
It can call on the old guard, on APIs, on traditional software services, whatever it needs.
And then there's the most critical piece, I think, the part that's often overlooked but mirrors how we humans improve, the ability to learn from a mistake.
That is the reflection mechanism. This is the critical feedback loop. If the agent's initial plan fails, the reflection mechanism allows it to self-correct. It analyzes why the failure happened and then generates an improved plan. It's how the system moves beyond just following instructions to genuinely improving its performance over time.
And connecting all of these adaptive parts to the legacy systems, managing the entire workflow, that's the essential, almost invisible layer we call orchestration.
Yes, think of orchestration technology as the nervous system of this whole collaborative enterprise. Its purpose is to manage the flow of work and really to reconcile two conflicting philosophies. You have the deterministic precision of RPA on one side and the adaptive reasoning of AI agents on the other. It ensures the right system is used for the right task, making this whole unified intelligence idea practical enough to deploy at scale.
Okay, let's shift gears completely from the software logic to the physical reality. When we hear about limitless AI, the scaling of this autonomous intelligence is actually being dictated by very tangible constraints. We're talking about infrastructure bottlenecks that have absolutely nothing to do with code.
That's so right. The scaling of enterprise intelligence and the sheer capital investment it takes is currently being held back by physical realities, things like power grids and construction delays. The readiness problem isn't about the algorithms. Deployment is being paced by limitations in securing massive amounts of power, cooling, and the sheer construction timelines for these mega data centers that house all the modern AI hardware.
Wow.
These new chips, they demand exponentially more electrical infrastructure than legacy computing ever did.
So you're saying the single biggest blocker to AI adoption isn't algorithms or software? In many places, it's literally building things with cement and steel.
Cement, steel, and making sure you have enough power capacity? In many regions, yes. And what's more, enterprises are showing some very strategic capital timing. They're deliberately delaying full-scale deployment, not because they doubt AI's value, but because they're waiting to maximize the performance-to-cost ratio.
So waiting for the next chip.
Exactly. We're in a period of such rapid hardware advancement. Training and inference costs are dropping so fast with each new chip generation. If you just wait 12 months, you might get 20% more performance for the exact same capital outlay. That patience is a really smart financial decision.
And we see evidence of this immense demand pressure everywhere, right?
Yeah.
Like the ongoing memory shortages and specialized high-end components.
You are listening to the AI World Podcast, your trusted source for the latest innovations, insights, and trends in artificial intelligence, blockchain, fintech, and decentralized technologies. Each episode features expert interviews, engaging discussions, and in-depth analysis of how AI transforms industries worldwide. Stay ahead of the curve with the latest articles and exclusive reports from the AI World Journal, covering everything from emerging technologies to industry breakthroughs. For more news, global events, and access to AI World Society circle gatherings, visit us at aiworld.tv. Don't forget to subscribe to stay informed, stay connected, and be part of the AI revolution with AI World Lounge. Thank you for listening.
Shortage is a crystal clear signal of the global appetite. It means the demand is so intense that the supply chain is just constantly stressed. And that allows the semiconductor segment to maintain really strong profitability, even while they're scrambling to meet this incredible global hunger for high-end AI compute.
Which naturally brings us to the economics. The total cost of ownership, the TCO, for enterprise automation has just fundamentally changed. We're moving away from OpEx operating expenses related to human labor and toward these massive capital expenditures.
The investment focus shifts radically. You are moving from recurring OpEx like wages and benefits, which are predictable, they're monthly, to scalable fixed cost CapEx investments in infrastructure and inference.
And inference means what exactly?
Inference is the running cost, the cost of the GPU cycles, the token consumption of the LLMs. This requires a completely new accounting model. Companies have to fundamentally change how they budget for a 5-year automation strategy. It's a profound financial shift.
So beyond the cost of buying the GPUs in the first place, what are the new cost factors that these TCO models absolutely must incorporate now? The things they didn't have to worry about with simple RPA.
Okay, 3 big ones. First, the raw ongoing cost of compute inference cycles. These are utility-like costs. They're based on usage. Second, the ongoing expense of data curation and RAG pipeline maintenance. RAG, retrieval augmented generation, that's how we feed the LLM fresh, contextual, high-quality data.
Right.
And maintaining that data integrity, keeping it fresh in real time, that is a significant ongoing investment. And crucially, the third factor, the extensive costs related to the governance, audit, and explainability frameworks you need to manage these probabilistic agents safely.
It's not just about the silicon. It's about the massive supporting infrastructure to make sure the system can be trusted and stays compliant over time. And speaking of infrastructure, we're seeing this dual deployment model emerge, edge versus core AI.
Correct. Core AI that's typically centralized on massive hybrid or public clouds. It focuses on the really resource-intensive tasks like massive model training and centralized large-scale data processing. That's your big central brain.
So if core AI is the massive central university library with all the deep knowledge, what's edge AI?
Edge AI is the highly distributed intelligence. It's the equivalent of the pocket calculator or the tablet that has the real-time knowledge right there in your hand. This is the fastest growth area today because it enables ultra-low latency, real-time reasoning right where the data is generated.
So like a factory floor.
Exactly. Think about a robotic arm on a manufacturing floor that needs to correct an error in milliseconds. Or autonomous transportation systems. That kind of speed can't wait for a round trip to the central cloud.
So the observation from the source material is that the future of enterprise intelligence isn't purely centralized. It is, without a doubt, distributed.
Okay, let's pull the lens all the way back to geopolitics. This brings us to a concept that is driving massive capital investment from nations globally, often even overshadowing corporate spending, and that is sovereign AI. This goes way beyond simple demands for, data localization. Why is this such a strategic national priority? Because it acts as the ultimate trust anchor for a nation's digital future. Sovereign AI means that the entire AI technology stack, from the chips in the data centers all the way to the foundation models and deployment platforms, is controlled and governed locally. And this is critical for, let's say, 4 high-level reasons.
Give us the big one first.
Geopolitical autonomy.
Yeah.
Simple as that. Nations want to mitigate the severe risk of an AI embargo, of being cut off from foreign infrastructure, foreign models, or foreign supply chains during a crisis. If you don't control your own intelligence infrastructure, you have a massive strategic vulnerability.
So domestic control equals long-term security. What about regulation?
That's number 2. It ensures regulatory alignment. Building a sovereign AI infrastructure guarantees that the entire tech stack adheres strictly to specific national laws and ethical guidelines. I mean, think of the EU AI Act as a perfect example of local standards driving the requirements for the underlying technology. It establishes a kind of regulatory moat that favors locally compliant solutions.
And economically, it's about where the money flows.
Absolutely. It reverses what many developing nations are starting to call digital colonialism. By mandating investment in domestic compute infrastructure, the capital, the jobs, the economic surplus generated by the AI revolution, it all stays within national borders rather than constantly flowing out to foreign hyperscalers. And that all leads to the final goal, which is that strategic trust, guaranteeing the compliance you need to deploy autonomous agents in sensitive regulated sectors, ensuring national security and confidence.
That need for domestic control is crystal clear. But let's go back down to the technical trenches. That strategic trust. It doesn't solve the messy technical problem of integrating the old and the new. What is the real complexity of combining deterministic RPA with probabilistic AI agents on the ground?
This is the technical handoff challenge, and it is the hardest part of deployment. The orchestration layer is where this battle is won or lost. It has to reliably convert the probabilistic reasoned decision of the AI agent, which is inherently flexible, a bit messy, into a structured, deterministic command that the RPA bot or any legacy API can execute without failure. It's like trying to translate a philosophical idea into a single, precise line of code.
And the agents are just starved for the data that's locked up in all these legacy systems, right?
Precisely. Legacy systems often lock up the rich contextual data that these AI agents desperately need to make high-quality decisions. This forces enterprises to build new, very complex API wrappers and robust R pipelines just to feed the LLM with high-quality, real-time context. It's a huge effort just to make the data accessible.
And finally, we come back to governance. This is so essential for anyone listening who's prepping for deployment. How do we ensure these autonomous, non-deterministic agents stay compliant and auditable, especially when they're making their own plans?
You need a comprehensive system. First, the system must implement a reasoning audit trail. This is paramount. It doesn't just log what action the agent took, it logs why the AI agent made a decision, the steps it considered, the data it looked at, the probability thresholds it used. This is what gives you the auditability you need.
Got it. The why, not just the what.
Exactly. And concurrently, you need programmatic guardrails. These have to be enforced to keep these non-deterministic agents strictly within predefined compliance boundaries. They prevent them from, say, accessing sensitive data or executing unauthorized transactions.
So when you put it all together, what does this mean? The evolution to autonomous intelligence is really the creation of a powerful new enterprise utility. The combination of that reliable RPA foundation with these adaptive AI agents, supported by sophisticated orchestration and anchored by localized sovereign infrastructure, it transforms automation from a simple cost-cutting tool into a core driver of strategic growth and national competitiveness.
It does.
And the biggest misconception that AI is going to replace RPA is just fundamentally wrong. AI extends and elevates it.
Which I think raises a really important final question for you, the listener, to consider as you map out your own strategy. Given how absolutely critical the reasoning audit trail and these programmatic guardrails are for compliance, especially in sensitive regulated sectors like finance or defense, what is the practical limit of autonomy that those sectors will ever allow an AI agent before a human review must interrupt the process? When does the regulatory need for that ultimate trust anchor outweigh the raw speed?
Something to mull over as we all accelerate toward this truly autonomous future. We'll catch you next time for the next deep dive.
The future of artificial intelligence is unfolding, and it's happening at AI World Week, the flagship global event for innovation, collaboration, and transformation. This flagship global AI event is designed to connect visionary leaders, trailblazing entrepreneurs, and influential thinkers to explore the endless possibilities of AI. Experience groundbreaking technology that redefines industries and inspires progress. Join thought-provoking discussions on ethical AI, digital equity, and the transformative role of technology in our world. Build meaningful connections that catalyze innovation and drive impact. AI World Week is powered by AI World Society, a global movement dedicated to advancing AI responsibly and ensuring it serves humanity. Together, we're shaping a smarter, more inclusive, and equitable future. Continue your journey beyond the event with the AI World Journal, offering expert insights, in-depth analysis, and the latest trends shaping the AI landscape. This is your opportunity to lead, to innovate, and to transform the world with AI. AI World Week. We invite you to join us and embrace the AI revolution.